Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at solving inequalities. So inequalities are like equations, except instead of an equal sign, they have one of these less than or greater than symbols. The way we solve these inequalities is just as we would for equations, except this one difference I've listed up here. I will show you that in a second. So let's solve this just like we would a normal equation. X is in one spot already, so we want to undo what's been done to x in the opposite order of bit mass. So what we did to x here is we divided by 4 times by -1, that's how we change the sign of something. Then we added 30 to get 12. So I'm going to undo the adding 30 first because it was the last thing done. I'm going to subtract 30 from both sides. Just like for equations, what you do to one side, you must do to the other. So those 30s cancel out. I'm left with negative x over 4 is greater than or equal to 12 minus 30 is negative 18. So what I'm going to do now is I am going to multiply by 4. I'm going to undo dividing 4 by multiplying by 4. So what I'll get is negative x is greater than or equal to negative 72. But I want x by itself, not negative x. So what I need to do to the left-hand side is I need to times by -1. What you do to one side, you must do to the other. Now, when we are solving inequalities, if you ever times or divide each side by a negative, you have to reverse the inequality. That's the one thing that's different to equations. So negative x times -1 is just x, but I have to reverse this to a less than or equal to. I do that whenever I multiply or divide each side by a negative. And negative 72 times -1 is just 72. So when we found our solution, we graph it on a number line. So 72 is the number I'm interested in. So I'll just put that at the center of the number line. Remember, numbers get larger as you go to the right and they get smaller as you go to the left. Now, if you're graphing a less than or equal to or greater than or equal to, you shade in the circles. So I'm going to put in a shaded circle above 72. Because it's less than or equal to, I'm going to draw an arrow that points to all the numbers less than or equal to 72. Okay, let's look now at this inequality here. My first job is to get x by itself. These fractions are annoying. So what I might do is I might get rid of them by multiplying by 4 and then multiplying by 3. So I'm going to multiply first each side by 4. So I have to multiply each of the 3 terms by 4. That means 7 times 4. Now, when I multiply negative x over 4 by 4, remember I'm doing it because these cancel out. I'm just left with negative x. And on the right-hand side, when you multiply a fraction by a whole number, you only multiply the top. So this will become 4x over 3. Only multiply the top by 4. So now I want to get rid of this fraction. I'm going to multiply by 3. What I do to one side, I must do to the other. I have to multiply each of these terms by 3. So 28 times 3 is 84. Negative x times 3. And then on the right-hand side, of course, the divide 3 times 3 cancel out. I'm just left with 4x. So just as I would for equations, I want to get x by itself, so I'm going to get rid of this by adding it. I'm subtracting negative 3x, which is the same as adding 3x to both sides, because if I add 3x to the left-hand side, then they get rid of each other. So what I'm left with is 84 is greater than 4x plus 3x. Divide each side by 12, you get 7 is greater than x. That's the same as saying x is less than 7. So to graph this on a number line, I'm going to put 7 in the middle. Numbers get larger to the right, smaller to the left. Now this time I have a strict inequality. It's just a less than, not a less than or equal to. So I use an open circle over 7. Once again, I'm going to point to the numbers less than 7. That is my answer done. All right, let's now look at some nested inequalities. So nested inequalities are like this. Basically, we have two inequalities nested into one. So to solve this, what I can do is solve them separately. The first part of the inequality says x minus 3 is less than 2x plus 6. So let's solve that. I am going to subtract x from both sides because I want to get x so that it's in only one spot. Now I subtract 6 from both sides, I get negative 9 is less than x. Of course, that's the same as saying x is greater than negative 9. Now I'm going to do the second part of the inequality. So 2x plus 6 is less than x plus 3. So to solve this, I want x in one spot. Again, I'm going to subtract x from both sides. Subtracting x from the left-hand side, I get that. Subtracting x from the right-hand side, I get that. So now again, I'm going to subtract 6 from both sides. I get x is less than negative 3. So the solution to this, anything will work that is greater than negative 9 and less than negative 3. So I can write that in one nested inequality as negative 9 is less than x, which is less than negative 3. You read this as x is between, but not including, negative 9 and negative 3. Just like for all inequalities, there are infinitely many solutions. Any number between negative 9 and negative 3, but not including those, it will satisfy this inequality. If I substitute x for a number like negative 5, for example, here, here, and here, I will get a true statement. So how do we graph this on the number line? Well, nice and easy. I'll put negative 9 over here, negative 3 here. I'm going to put a circle above each that's unshaded because these are strict inequalities. I'm not including negative 9 or negative 3 in my set of solutions. I simply draw a line now between them. So this is how we graph that x is between but not including negative 9 and negative 3. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.